three people are shooting at a target. Their respective probabilities of hitting the target are 0.8, 0.7 and 0.4. So they have different probabilities of hitting the target. Find the probability that the target is hit. Okay, the target is hit. Well, there's different probabilities for each of these people to hit the target. So it means at least one of them is hit. So even if one of them don't hit, as long as one of the other two hits, then we still treat it as the target being hit. So it means that one person hits the target, two people hit the target, three people hit the target, but we don't want none of them to not hit the target. We should subtract one from all of them failing to hit the target. You get the idea? So that makes it equal to at least one of them hitting the target. So all we need to do is find the probability that all of them fails, which means 1 times 1 minus 0.8 times 1 minus 0.7 times 1 minus 0.4, because those are the complementary events of hitting the target. So multiply them all, subtract it from 1, and that's what you should get. Do you get the idea? A box contains 4 times the number of 10 cents as 5-cent pieces. So we've had this particular question before, haven't we, requiring the 10-cent coins and the 5-cent coins. A coin is randomly withdrawn from the box and replaced. This is done 3 times. Now, as it says, the 10-cent coins is 4 times the 5-cent coins. So the ratio would be 4 to 1. So the probability of 10-cent coins would be 4 out of 5, and the 5-cent coins will be 1 out of 5, because the total parts is 5, isn't it? So those are the probabilities of those individual events. Now A, find the probability of getting at least one 5-cent piece. So we want at least one 5-cent piece. It means I could have one 5-cent piece, 2 5-cent pieces, or 3 5-cent pieces, but I don't want no 5-cent pieces. So it's going to be 1 minus the probability of having no 5-cent pieces, which means I'll have 3 10-cent pieces, isn't it? So it'll be that. So it'll be 1 minus the 10-cent pieces times 3 times. It's going to be multiplied because it's 10 cent, 10 cent, and 10 cent. It's and. So we multiply. And that's what you should get. Okay, so you subtract it from 1 again because it says at least. Now B, find the probability of not getting 3 5-cent pieces, of not getting. So this is the opposite of getting 3 5-cent pieces, which means not getting 3 is the complementary of getting 3. So I should subtract getting 3 5-cent pieces from 1. So it will be 1 minus the probability of 5 cent and 5 cent and 5 cent, which is 1 minus 1 over 5 times 1 over 5 times 1 over 5, 3 times. That would be this. Okay, do you get the idea, guys? 2 cars are available for rent in a rent-a-car shop. The probability that any of them is available for renting is 0.85. So there's a probability that the car is available. Now, find the probability that no car is available. Okay, well this is the probability that the car is available. So the probability that's not available would be the complement, which is 1 minus 0.85. So if both of them are not available, it would be 0.15 times 0.15, because this is 0.15, isn't it? So 0.15 times 0.15 is the probability that both are not available, and that should be how you simplify it. Okay, so that's A. And B, find the probability that any car is available. This is the probability that it is available. Now that's the probability that none of them are not available. So I can say 1 minus that, because if it's available, it's the opposite or the complementary or complement of when it's not available. So we simply subtract that from 1 to get the remaining, which represents the probability that any car is available.